So we were checking out, I've always heard as a rumor that Loctite type anaerobic bonders, I'm gonna go away from the brand name, were basically good as long as they flowed. You know, basically once they set up, of course you can't flow them into a joint, but until they set up. And since I was at a point where some that had been shipped recently, I ordered a bottle. It's supposed to be here next day. Well, 4 days later it got shipped. So we're not getting it the next day. I have something I want to add a little bit of extra retaining compound on. So we did a test here, and we just put it on the simplest thing, a bolt and a nut. But an observation was made that was rather interesting, and that is that it actually stuck to the table just from the flat side laying there. So obviously it does still work, and I hadn't broke it loose yet because we just put it on video. So, yeah, wasn't fully set up yet, but it did apparently still work after some time, and I'm not even so worried about the threads now that I saw it just plain glued on there pretty good. So I'm going to say that, yeah, it still works after it's over 10 years old, as long as it's still liquid. So now, what we're looking at using that for, which I talked about before, and combination of sometimes you have wrong ideas. Well, all of your ideas at the end of the day are right, because when you're done, it worked. So then they're all right. Bore this out, sleeve it for the valve body. This is for the transmission. We've talked about this before. My original concern here was I wanted to be able to put in a sleeve that was a little bit thicker and then bore it out afterwards, or even close to size, but be able to bore it out. The alignment, there's multiple steps here that I cannot get to do anything with, and are the correct size and not worn. So I need those to line up with this bore, and this bore should have 1/1000 clearance. So it's really, really close stuff. So I really didn't want to move it off the machine after putting the sleeve in. Well, it finally dawned on me. Initially, I wanted to do it with a, and you can do it with liquid nitrogen, but getting it in here, if it starts to caulk a little bit, it binds where you got to pull it, you know, and we can do a light press. Well, light press and tap it in with a hammer, now it might move in the mill a little bit. It just doesn't take anything. But on the other side of all that, as I said, there's always, you know, sometimes as other things have kept me away from finishing this little step, it's really simple. It's called all thread and 2 washers. I've done it 100 times on things. Why I didn't think about it sooner, I don't know. But that nice, smooth, easy, you don't move anything, it just sucks it in. And that's what we'll do. I will leave it a light press fit along with the anaerobic bonder. What I was going to do before, when I was worried and couldn't figure out the absolutely obvious method, was to make it a slip fit, which is also commonly done on these. Just a 5/1000 clearance, put the anaerobic bonder around it, and then lock it in. And that would be, and then I'd definitely leave some area after it's set up for a while to rebore the inside, because it might float and move a little bit from one side to the other. But yeah, we'll do a light press with the binder just to be sure. The other thing, since I know now I could do a light press, I could do either medium press or a hydraulic pneumatic sealer in there instead of the actual bonder. Not that much of a difference either way. And then to be sure that there's not a loss, just for one extra thing, I will put a screw through here somewhere and thread in it and grind the brass screw off so that it's not, so it's got a pin where if for some reason something else happens, it won't be rotating. Be nicer to have an oversized valve body. We talked about the possibility of just plain plugging it and doing it with an external valve body, but there's always trade-offs, trying to get the most best way that is functional. We're working on the bell housing some more. I hadn't caught up with Austin. I don't know if he got further since I went away for lunch, actually, in between here. And no, not yet. We made a boo-boo, and Austin was making the fixing tool, and he's about to build it. So we can just show you what's going on here. So here is the problem. This is the fixing tool. Here's the problem. This hole, and this hole were supposed to be countersunk. That's, right over steel. They were supposed to be countersunk before we welded this plate on. My mistake, totally. If I would have been welding it on, I would have caught it because I would have been doing all of it, but it's my fault. I'm the boss. And yes, it should have been done first. We could cut a little hole out here. I don't want to. That's just wrong. That's wrong. We could make a special offset step U-joints and get in there and be nasty. What we're doing is we're making a cutting tool here, and Austin was getting ready to braze the carbide into it for the angle. And what this will do is it will go through, and then you take a drill and you drive it to cut. And it's that way. I knew he was cutting it right. It just looked wrong. Yeah, the insert was laying upside down. It goes this way. I knew he had it right on the milling machine. So it goes like that, just parallel with the surface. That will cut your 41 degree per side or 82 degree included. The reason for those, and you're like, well, why? The reason for that is because when you look at this, and this is where the bell housing couldn't be changed the way we were looking at it at first. This flywheel, and yes, we could change a whole different flywheel. We could do a lot of things to try and make it all work. But this flywheel, the ring gear is overlapping that bolt hole, and this bolt hole. Those three have got to be flathead screws. Use standard bolt there, and there because of the size. The way that Ford took care of that in this original application is where long-term the problem came from. And, well, even short-term, because even when it was fairly new, it was just, they made it wrong a little bit. It was off-center. But what was happening here, and I sure really wouldn't have thought it would, but we came up with, right along this line, this 1/4-inch plate got to where it just bends too easy. And trying to straighten it out, and you could say, well, why don't you make a thicker plate to put on here? Well, it'd be as much work getting a thicker plate made to this and making it right, and it'd be harder to line up than starting from scratch. But what they did was they used this plate to go on here, and the plate bolts to the engine. And so the plate bolts to the engine. This all goes behind that flywheel. And then the plate, which over the years has gotten wonky where it bends easy, doesn't look that bad, but you put an indicator on here and you just barely grab it at the bottom and it's 25 thousandths with your fingertips. It was amazing. I was blown away when I saw it. Yeah, it doesn't look that bad, but it was terrible. And the reason is you got the plate and then you move out to your bell housing. This 1/4-inch plate is actually the only thing that's holding the bell housing, the motor mount, everything. And if I could have found a brand new bell housing, brand new plate, I looked a little bit, I might have still been disappointed, but I definitely was considering it. Not against buying parts, but not as good of a design. Now, so the thing is, that same space that they originally made for a 1/4-inch that just barely fits with the bolt heads and is almost a problem behind the flywheel, we put a 1/2-inch plate in ours that we welded together. So it is a problem behind the flywheel. And that's why we have to do the countersunk screws and why we're using a tool. I've made tools like that quite a few times. People, I'm sure, many people in the industry, I just dropped the insert out of it, but this will go through the hole, which it doesn't right now because we're coming in at an angle. It'll get cut off. But it'll go through the hole, and then you run it with a drill from the other side, and you pull it towards you to cut. And they work. They work. We do also these holes here, the particular ones that we are putting the counter sink on. Those ones were originally water jet cut holes. The ones here and here are the precision holes for the dowel pins, but those holes were cut with water jet. So the first thing we have to do is run a 17/32 drill bit in there to clean them up just a little over the 1/2 inch so they're nicer to pilot the tool. And that won't be a problem as far as the size for the, well, it's not a size for a washer or bolt anymore. It is for a countersink. It will pull. It's going to bind on one side a little more than the other, but it just will. But I'll wait for the next thing I was going to say. But I guess I can put it in here too. But we'll just put it in twice when we're talking about the next step here that we want to film. Film. That's an antique idea. But is when you're doing one of these bell housings and you get down to the point that you put it on the engine and you start dialing in to figure out where you really are at the final end for your transmission to go on. And I see a lot of people having trouble with this and not knowing it. They're showing using the eccentric dowel pins. You see that on a lot of people. All of a sudden they've woken up to realize that some of this does damage transmissions. So I'm seeing a lot of people that, 30 years ago, nobody even talked about it. I just once in a while check it and I'm like, whoa, that's bad. And the mechanics that I ran with that were doing hot rodding pretty much, yeah, who cares? Factory made it, it's got to be perfect. I'm seeing the eccentric dowel pins to try and adjust a bad bell housing setup, but something they miss that's critical. When they built their engine, before they bored it, before they honed it, they made sure that the machine shop put torque plates on there. Before you dial this thing in, torque the bolts all the way. Tighten them down. It is amazing how much it can move from torquing it. Bolt it down before you check the dialing. And have a wonderful another day after watching this and commenting and all that good stuff. Thank you.